Hi guys. All right, let's start with May June 19 variant 1.1. So let's see the first question. Temperature of sample of an inert gas is increased. So you're changing the temperature. As we change the temperature, what happens to the number of particles with activation energy or more? So as we increase the temperature, we know that the number of particles having energy greater than activation energy increase. Yes. So having energy greater than the activation energy, they increase. So the ones with high energy, molecules with high energy, they will increase. And we know that the number of particles should stay the same. So if you increase the temperature, the number of particles having energy greater than activation energy will increase. Therefore, the ones with probable energy or less energy will decrease because the number of particles must stay the same. So if this is increasing, this should decrease. Yes, because now more particles of energy greater than activation energy. So this will decrease and that will increase. The answer is B, at high temperature. Uh, Question number 2, a sample of element X is analyzed using mass spectrometry. Mass spectrum is obtained. What is the relative atomic mass of this sample of element X? How do we calculate the AR? AR is isotopic mass times the abundance upon the total abundance. So it would be 3 times 112 plus 56 times 114 plus 41 times 115. All of that divided by the total abundance, which is 3 plus 56 plus 41. And this comes out to be 114.4. The answer is D. A washing powder contains sodium hydrogen carbonate as one of the ingredients. So you have sodium hydrogen carbonate. This reacts with sulfuric acid. They are saying in a titration, 1 gram of the washing powder reacts with this much sulfuric acid for complete reaction. Sodium hydrogen carbonate is the only ingredient that reacts with acid. So let's see the reaction of sodium hydrogen carbonate with sulfuric acid. So this will be complete reaction. So this will make sodium sulfate plus water plus carbon dioxide. Let's balance this. You have 2 sodium here, you put a 2 here. Then you have 2 carbon dioxide here, so we put a 2 here. And then we have a total of 2 and 2, 4 hydrogen here, so we put a 2 here, and it is balanced. Now, let's find the moles of sulfuric acid. That would be N is equals to C times V. The concentration is 0.1. The volume is 7.15 cm cube. So you divide it by 1000 to make it into dm cube. So that becomes 7.15 divided by 1000 times 0.1. That's 7.15 10 to the power minus 4 moles of sulfuric acid. Once you find that, you need to find the percentage mass of sodium hydrogen carbonate. So let's find the moles of sodium hydrogen carbonate. That would be 7.15 10 to the power minus 4 times 2. Yes, because the ratio is 2:1 and we have the moles of sulfuric acid. So the moles of sodium hydrogen carbonate would be 1.43 10 to the power minus 3 moles. Once we have the moles, can we convert it to mass? Yes, we can do moles is equals to mass upon molar mass. So moles are 1.43 10 to the power minus 3. Mass is X. MR of sodium hydrogen carbonate is 23 plus 1 plus 12 plus 16 times 3. So you multiply the moles by the MR and that gives you 0.12 grams. Once you find the mass, you need to find the percentage. The total grams of or the mass of washing powder was 1, out of which sodium hydrogen carbonate is 0.12. So 0.12 out of this is sodium hydrogen carbonate. So 0.12 divided by 1 times 100, that gives you 12%. The answer is C. Question number 4. The outermost electron in the atom of neon occupies a particular orbital. Neon has 10 electrons. So the configuration is 1s2, 2s2, 2p6. So which row shows the relative energy and shape of this orbital? So we know the outer orbital is 2p and the shape is dumbbell. Can't be B, can't be D, because these are spherical s orbitals. Yes? Now, energy of the orbital relative to the other occupied orbitals. So the other occupied orbitals are 1s, 2s, 2p. So you know that as we go away from the nucleus, the energy of the orbitals increases. Therefore, 2p will have higher energy. Yes? So the answer would be A. Which species is there a lone pair of electrons? Not in CH3, because in CH3 you have carbon with 3 bonds. The 4th electron will be right here, not a lone pair. Can't be the answer. CH3 plus, that means you have lost the electron. So that 1 electron that was unpaired is now lost. Can't be a lone pair. CH3 minus, that means you have gained an electron. So carbon has 4 outer electrons, 1 is right here, and you've gained 1. So that will be a lone pair. The answer is therefore C. Question 6. When an evacuated tube of volume 400 cm3 is filled with gas at this Kelvin, 101 kilopascals, the mass of the tube increases by this much. You need to find the identity of the gas. So PV is equals to nRT. Instead of N, we can equate mass upon MR. RT. Pressure right here is given as 101 kilopascals. Let's convert it to pascals. 1 kilopascal has 1000 pascals. So 101 would have 101 times 1000. So it's 101 times 1000. Volume is given to you in cm cube. Let's convert it to meters cube. 1 meter cube has 10 to the power 6 cm cube. So 400 cm cube would have x, and that x is 400 divided by 10 to the power 6. Or you can write it as 400 times 10 to the power minus 6. Mass is given as 0.65. MR, we don't know. And value of R is 8.314. And temperature is given to you as 300 Kelvin. When you find the value of X, the value of X would be the MR, which comes out to be 40.1. If you see, that would correspond to argon. That has an MR of roughly 40, 39.9. So that's 40. The answer therefore is A. Under which conditions will nitrogen behave like an ideal gas? For ideal gas, we have assumptions. You should have no intermolecular forces, and you should have negligible volume compared to the total volume of the container. So negligible volume and no intermolecular forces, and this is possible if you have high temperature. At high temperature, particles are far apart. There will be less or no intermolecular forces between them. Yes, and at low pressure, because at low pressure, particles are far apart. So high temperature and low pressure are the conditions at which a gas can behave ideally. The answer therefore is B. Question number 8. What is the value of X? So you need to find this delta H. So let's see. So this is your box 1, box 2, and your box number 3. Carbon, 2 moles of carbon becoming C2H4. So this right here, carbon with hydrogen becoming C2H4. This is plus 52.2. Then C2H2, which is right here, C2H2 plus hydrogen becoming C2H4. This is minus 175.8. So this is your third box. Now let's find the start and the stop, or the start and the end of the reaction. So this right here, where you have maximum tails, is the start of the reaction, and where you have maximum heads is the end of the reaction, and this is the intermediate. You can go from start to end directly, which is equal to start to intermediate to end. That's what law of thermodynamics says. Start to end, what is the value? Plus 52.2, which is equal to start to intermediate, that is X, plus intermediate to end, that is minus 175.8. And then you find the value of X, that is plus 228. The answer therefore is D. Ethane dioic acid can be oxidized by K-4 in a dilute sulfuric acid. Product of the reaction, the carbon dioxide, water, potassium sulfate, and manganese 2 sulfate. The reaction of each of the dioic molecule loses 2 electrons and is oxidized, and the equation is shown. So the half equation of the oxidation here is shown. How many water molecules are produced when 5 ethane dioic molecules are oxidized by K-4? So you have the half equation of ethane dioic acid. You will find the other half equation, which would be of manganate ions. Right here, if you see, It is KMnO4, so that should have MnO4 minus. And this is in sulfuric acid, so that means it's acidic. So that must be MnO4 minus in acid, in H plus. Giving you, they are saying manganese 2. So that means it should give you Mn2 plus. And that is formed right here in this equation. Yes? So this becomes your other half equation. Acidic MnO4 giving Mn2 plus. So let's write down this half equation. So you have one half equation, which is right here. And the other one is MnO4 minus plus 8H plus 5 electrons, giving Mn2 plus 4H2O. Now, this is a redox reaction. As you see, this one is getting oxidized, losing electrons. This is gaining electrons, reduction. And now we need to write the overall equation and find out the moles of water. Yes, how many water molecules are produced? When you do that, in order to write the overall, you must ensure electrons on both sides are equal. This is losing 2, this is gaining 5. Electron exchange must be equal. So you multiply this equation by 5 and this by 2. And when you do that, you have 5 moles of ethanedioic acid. Yes. So the total would be 5 moles of HO2CCO2H. Yes. So ethanedioic acid would be 5 moles when you balance it. And that's exactly what they're asking. How many water molecules are produced when 5 molecules or 5 moles of ethanedioic, they are oxidized. So when 5 are oxidized, how much water is produced? 4 twos are 8. You don't need to write the overall equation. You can just find the moles of water, which will be 4 twos are 8 moles of water. Therefore, the answer is B. Hydrogen iodide gas decomposes reversibly, producing iodine vapor and hydrogen. The equilibrium reaction right here is shown. Delta H is given to you. Which row correctly describes the change in position of equilibrium? Increasing pressure. If you increase pressure, system tries to decrease it. It will favor the side with less moles of gas. But you see in here, you have equal moles of gas on both sides. So when you change pressure, there will be no change. Therefore, the answer can't be A or B. Let's see the second option right here. Effect of increasing temperature. Forward reaction is endo. If you increase temperature, system will try to decrease it. It will favor the endothermic side, which in this case is the forward reaction. So equilibrium will shift to the right. Therefore, the answer is C. Question 11. Reaction between sulfur dioxide and oxygen is reversible. Kc is given to you. In equilibrium mixture, sulfur trioxide concentration is this much. Sulfur dioxide concentration is twice the oxygen concentration. So we have 2SO2 plus O2 giving 2SO3. This at equilibrium is 6 moles per dm cube. This we don't know. This is X. And they've told you sulfur dioxide is twice the amount of oxygen. So if oxygen is X, this will be 2X. Now you know Kc is equals to concentration of products raised to the power of their moles or molar coefficient upon concentration of reactant raised to the power of its molar coefficient. Kc is 280. Sulfur trioxide is 6 raised to the power 2. Sulfur dioxide is 2x squared, and this would be x. So it is 280 is equals to 36 upon 4x cubed. And when you find the value of x, that comes out to be 0.317 moles per dm cubed. But we don't want that. We want to find the concentration of sulfur dioxide. So what is the concentration of sulfur dioxide? It is not x, it is 2x. So concentration of sulfur dioxide is 2 times x. Therefore, it will be 2 times 0.317, and your answer is D. 1.15 grams of metallic element needs 300 cm cube of oxygen for complete reaction. So let's see. Now let's convert these metals to the metal grams to moles. So calcium plus oxygen giving calcium oxide plus oxygen giving magnesium oxide plus oxygen giving potassium oxide plus oxygen giving sodium oxide. Let's balance it. So this will be half, half. This will be 2 potassium and half oxygen, 2 sodium, half oxygen. Let's find the moles of these metals. So that would be 1.15 divided by the AR. What is the AR of calcium? It's 1.15 upon 40. So the moles come out to be 0.0286 moles of calcium. Likewise, this comes out to be 0.047. This comes out to be 0.029. This comes out to be 0.049. Once you have the moles of these metals, let's find the moles of oxygen. Here, oxygen is in the ratio of 1:half. So if this is 0.0286, this would be half of that. And when you find the moles of oxygen, they come out to be 0.0143. And when you find the moles of oxygen, you now need to find the volume. So you will multiply this by 24,000. And when you do that, why 24,000? Because it is in cm3. You get the volume, which comes out to be 343.2. Can't be the answer. And when you check for B, again, the volume comes out to be 564 cm3. When you check for this, comes out to be 174 cm3. With sodium, the volume comes out to be roughly 300. The answer, therefore, is D. So basically, we find the moles of sodium, which is 1.15 divided by 23.1. Once you find the moles, so you know the ratio is 1:half. So whatever the moles are, which are 0.0497, you will find the moles of oxygen. Once you find the moles of oxygen, the ratio is 2:half. So it's 2:half. So you find the moles, they come out to be 0.0497. You find the moles of oxygen and multiply it by 24,000, and the volume comes out to be 298.7. So roughly 299 cm3, and that is 300 cm3 here. The answer is D. The relative melting points of 4 consecutive elements in the periodic table are shown. The elements have proton numbers less than 20. Which element is group 16? Now, if you remember, across the period, in period 3, we did the trend of melting points. What was the trend? This was sodium, magnesium, aluminum. There was a big jump to silicon because it is a giant macro molecule, so high melting point. There's a decrease. This is P4 phosphorus. Then there's an increase S8. Then there's a decrease Cl2. And then there is argon. So the highest melting point, or A, kind of corresponds to somewhat silicon, looks like silicon, or a group 4 element, group 14 element. Therefore, this will be group 15, this would be group 16, this would be group 17. Which is a group 16 element? C. Question number 14. Substance X reacts with water, gas is given off, and the pH of the solution increases. So pH increases when one of these react with with water. When you react this with water, you will get barium hydroxide and hydrogen. Do you see gas is evolved? Yes. Is the solution in alkaline? Yes. That's why the pH increases. So A can be the answer. Barium oxide with water will just give barium hydroxide. Will it give any gas? No. Because to oxide, when you add water, you get hydroxide only. So can't be B. Magnesium with water. When you add this, it will give you magnesium hydroxide and hydrogen gas. Yes. And is it going to be alkaline? Yes, because magnesium hydroxide is also alkaline. D can't be the answer. Why? Because when you add magnesium oxide to water, it will give you just magnesium hydroxide. So answer can be A or C. Then they are saying, whatever the resultant was, you added this to sulfuric acid. So when you add this to sulfuric acid, barium hydroxide with sulfuric acid will give you barium sulfate. This will give you magnesium sulfate. They're saying a white precipitate forms. Magnesium sulfate is soluble. Therefore, this can't be the answer. Barium sulfate is insoluble. It is a white precipitate. Therefore, the answer is A. Solution of 0.1 mole per dm cube magnesium nitrate and 0.1 mole barium nitrate separately undergo series of reactions. So magnesium nitrate to sodium carbonate would give you what? Magnesium carbonate. When you add that to excess HCl, that will give you magnesium chloride. When you add that to excess NaOH, that will give you magnesium hydroxide. Then barium nitrate to carbonate would give you barium carbonate. To HCl will give you barium chloride. When added to NaOH will give you barium hydroxide. So let's see which of these are white precipitates. Magnesium carbonate is a precipitate because all carbonates are insoluble. So these two are precipitates. Magnesium chloride, barium chloride are not because all chlorides are soluble except silver, lead. Magnesium hydroxide is a precipitate because it is insoluble. Barium hydroxide is not a precipitate because it is soluble. Solubility of hydroxides increases down the group, is why this is soluble, won't be a precipitate. Only three are. 1, 2, 3. The answer is B. 16. Concentrated sulfuric acid is added to separate solid samples of sodium chloride and sodium bromide and iodine. So we know that NaCl with H2SO4 undergoes a reaction where you make NaHSO4 HI. In this, H2SO4 acts as acid only because chloride does not get oxidized. It stays -1 to -1. It stays -1. So there's no change in oxidation state. Sulfur stays +6. Here also is +6. There's no change. So in NaCl, it acts as oxidizing. It acts as acid only. Let's see with NaBr. With NaBr, H2SO4 will give NaHSO4 plus HBr. This further reacts with H2SO4 to make Br2. You see, bromine goes from -1 to 0, and there is oxidation of bromine. So here it is acting as acid plus oxidizing agent. With NaI, with H2SO4, you make NaHSO4 plus HI. This HI further reacts with H2SO4 to make iodine plus H2S. Do you see? Iodide goes from -1 to 0. Again, it's getting oxidized. So here too, H2SO4 acts as acid and oxidizing agent. So where does it act as acid and oxidizing agent? With bromide and iodide. Answer therefore is C. Reaction of bromine with warm NaOH produces products the same way. The ratio is the same as chlorine with hot NaOH. So let's see the equation. Chlorine with NaOH will be the same as the reaction of bromine with hot NaOH. So that would be 3Br2 plus 6 NaOH, giving you NaBr 5 moles plus NaBrO3 plus 3 moles of H2O. The same equation of chlorine, but I've replaced chlorine with bromine. Instead of chlorine, I've written bromine because they said it reacts the same way. Now, in one reaction, 30.2 grams of product containing sodium, bromine, and oxygen is produced. So what is that product? Sodium, bromine, and oxygen. That is this guy. So let's convert the grams to moles. So that would be 30.2 upon the MR. So the MR would be Na, which is 23, bromine, which is 79.9, oxygen, which is 16 times 3. And the moles come out to be 0.2 moles of NaBrO3. Once you have the moles, they're saying what is the mass of NaOH that is reacted. So let's use this ratio and find the moles of NaOH. The ratio is 6:1. The moles for this were 0.2. So this would be X. Yes. And they're asking you the mass. So this would be 6 times 0.2, which is 1.2 moles of NaOH. Let's convert this to mass. So that would be moles is equals to mass upon molar mass. So that would be 1.2 is equals to mass upon MR. So for NaOH, it is 40. So 1.2 times 40, that would be 48 grams. Answer therefore is D. 18. At 550 degrees Celsius, nitrogen dioxide reacts with unburnt hydrocarbon fragments such as CH3 in catalytic converters of motor vehicles? Which row gives energy change for the reaction? The possible reason for it. So we know that in the catalytic converter, we have combustion reactions, yes, and those are exothermic. So A and B can't be the answers because they're not endothermic, they are exothermic. Now, what is the reason why they are exothermic? So we know these are exothermic reactions because carbon dioxide and H2O have negative formations. So if you remember, what is formation? Where 1 mole of a compound is formed from its constituent elements in their standard state. Can I call this combustion, formation of carbon dioxide? Can I also call this combustion of carbon? Do you see this is exothermic? Yes, because combustion is always exo. So even if you don't remember the formation of carbon dioxide and formation of water are both combustion of hydrogen and combustion of carbon. So these are formation of water and carbon dioxide. They can also be called combustion of carbon, combustion of hydrogen. And combustion is always exo. So this is true. Combustion or formation is exothermic. Their combustion, because we remember the combustion. We know combustion is always exo. So formation of CO2 is the same as combustion of carbon. Formation of H2O is the same as combustion of hydrogen. And we know combustion is always exo. So we can say their formations are exothermic, yes. Therefore, the answer is C. 19. Which statement is correct? Ammonia reacts with alkalis to form ammonium ion. So ammonia with alkali, no, ammonia with H plus makes ammonium. And H plus is not alkali, H plus is acid. Can't be the answer. Ammonium chloride. So let's see ammonium chloride. Ammonium chloride has ionic bond. Yes. Between ammonium and Cl minus, there is ionic bonding. In ammonium ion, you have covalent bonding and you have a dative bond as well with the H plus. So you have covalent, you have coordinate, and you have ionic bonds. Yes, the answer is B. Ammonium reacts with acid to produce ammonia. No, ammonium will not react with acid because ammonium itself is a conjugate acid. It will not react with acids, it will react with bases. Bond angle in ammonium is 107. No, it's 109.5. 20. All right. Diagram shows two different compounds. So you have one which is a ketone, both are ketones actually, and alkenes. Total number of structural isomers, including compound 2, that can be formed by adding a second methyl group to the ring of compound 1. So when you add another methyl branch here, they're saying how many structural isomers can you have? So the other methyl can go here. It can go here. It can go here. It can go here. It can also go here. Do you see you have 1, you have 2, you have 3, you have 4, which is the same as 2, which is the same as this. 4 and 1, 5 different positions. So how many number of isomers can we have? 5. Answer can be C or D. Then the number of pi electrons in each compound. Let's see how many pi electrons do we have. So we have 2 pi bonds. In a double bond, one is sigma, one is pi. So in the pi bond, you have 2 electrons. And over here also you have a double bond. So you have 1 sigma, 1 pi. In a pi bond, you have 2 electrons. So total pi electrons are 4. Answer is D. I'll do the remainder of this paper in the next video.